Hello everyone and welcome back to a brand new video, and in this video I'll cover problem C, that is zero sum prefixes. So let's start with the problem. But before we move on to the solution, I want to tell you guys about Newton School's coding contest. So Newton School organizes this coding contest every month. You guys can solve some quality problems and also compete against top coders in the world. This will be a good opportunity to benchmark yourself where you guys are lying in respect to other students in India or around the world. Not only that, along with this, you can also win some cash prizes. You can win rewards up to rupees 90,000. You can also win scholarships up to rupees 20,000. And along with this, there will also be some job opportunities. So this month, the contest will be on 30th of November. It will be around 2.5 hours from 9 p.m. to 11:30 p.m. So do not forget to sign up. The link will be in the description. So do go and sign up from there. So in the problem, we have been given an array A of size n, where n can be up to 10 to the power 5. So something like A1, A2, A3, so on up to An. We have also been defined something called the score. So score of the array is basically number of indexes I such that A1 plus A2 plus A3, so on up to AI is equal to 0. We want to maximize the score, and to maximize this we have been given an operation. The operation has two steps. In first step, you will choose some index I such that A of I is equal to 0, right? And in second step, you will set AI equal to some integer x. X can either be negative or positive, right? So it is an integer. So you will set AI equal to x. You can also write the second step as add x to AI, right? Because AI is equal to 0. So setting AI equal to x is basically saying we add some integer x to AI, right? So that is the operation. Given this operation, we have to find the maximum score that we can obtain. So given some array A and this operation, find the maximum score that we can get. Right? So let's see how we can solve this. So in the problem, we have been given that our score is A1 plus A2 plus A3, so on up to AI is equal to 0, right? That is the score. But this is basically a prefix sum, right? This is basically a prefix sum. So your score is basically number of prefix sums that are equal to 0. So you want to maximize the number of prefix sums that are equal to 0. So if I create a new array of prefix sums, I have my given array A1, A2, A3, A4, so on up to An. Let's say I create a new array P of prefix sums, P1, P2, P3, so on up to Pn. Here every element Pi is just sum of first I elements of A. So right, Pi is equal to A1 plus A2 plus A3, so on up to AI. So now your goal is to maximize the number of zeros in array P. Maximize zeros in array P, right? Because array P is an array of prefix sums, and you have to maximize the number of prefix sums that are equal to 0. So now our goal is to apply operations on indexes in A such that the number of zeros in my array P are maximized. Now how can we do this? So let's move on to the observations now. So the very first observation. Operation in A is just equivalent to adding x to suffix of P, right? So what we are saying is when we apply an operation in A, it is just equivalent to adding the value x to the entire suffix of P. So we can take an example to show this. So we have A1, A2, A3, A4. A5 so on up to AN. And we have P1, P2, P3, P4, P5 so on up to Pn, right? So let's say your element A4 is equal to 0. So we will apply an operation on A4. So let's say I set A4 equal to X, right? That means I have added X to A4. As my P4 contains A4, right? So my value of P4 will also increase by X. So P4 becomes P4 plus X. Similarly, my P5 also contains A4. So it will also increase by X. Similarly, all the elements up to Pn will increase by X, right? So if you do operation on A4, all the elements from P4 up to Pn will increase by X. So that is how the operation works in array P. So that is the first observation. Now let's see how we can use this to solve the problem. So for the second observation, we will try to find the optimal strategy. We will break this down into two steps. In first step, we will try to find the strategy if there is only one index where AI is equal to 0, right? So if there is only one index where we can apply the operation, first we will try to solve for this, and then we will try to expand the idea to the complete problem, right? So let's solve for this first. So I have A1, A2, A3, A4, A5 so on up to N. I have P1, P2, P3, P4, P5 so on up to Pn, right? Let's say your A4 is equal to 0 again. So this is the only element in the index which is equal to 0. So you can only apply operation on this index. For the value that are before P4, these values will never change. So score for these values is just number of zeros, right? So for the first three index, you will just count the number of zeros. Now for the later half, that is for suffix from P4 to Pn, you can add any value X to the suffix, right? So let's say your suffix is something like, it has, let's say, 4 5s, 2 3s and a 1, right? So now what value will you choose of X such that your suffix P4 to Pn has the maximum number of zeros, right? You want to maximize the number of zeros in array P. So you have to choose the value of X such that the zeros created here are maximized. And as you can see, we have 4 5s. So it is optimal to convert these 5s to zeros, right? Because there are maximum number of 5s here. So these 5s will give us the maximum number of zeros, right? So for the same reason, we will choose value of X equal to -5. So when we choose value of X equal to -5, all these 5s will be converted to zeros. So your score here will be how much? It will be score is equal to score plus 4, right? Because you converted these 4 5s to zeros. So your score will increase by 4. So that is a general idea. I hope you are able to get the optimal strategy now. So the optimal strategy is just to find the element that is most frequent and then apply the operation for that element, right? So the optimal strategy is just find the most frequent element. Let's say it is equal to F, right? And then set X equal to -F, right? If you do this, your score will increase by frequency of F. Score is equal to score plus frequency of F. So that is the optimal strategy when you only have a single index AI equal to 0, right? So for the suffix, you will find the most frequent element. Let's call it F. Then you will set X equal to -F and your score will increase by frequency of F. And as in the example, you can see we had 4 5s. So we set X equal to -5 and this will create 4 zeros. So our score will increase by 4. So score is equal to score plus 4. Now that is the case when you only have a single index AI equal to 0. So now let's try to expand this solution to the complete problem, right? When we have multiple AI equal to 0. So now let's move on to step 2. Multiple AI equal to 0. So let's say we have A1, A2, A3, A4, A5, A6, A7, A8, A9, so on up to AN. Similarly, we have P1, P2, P3, P4, P5, P6, P7, P8, P9, so on up to Pn. So let's say your A4 is equal to 0 and your A9 is also equal to 0. So we can only apply operations on these two indexes, right? When we apply operation on A9, it will take care of zeros from P9 to Pn, right? So when we are applying operation on A4, we don't need to think about elements from P9 to Pn, right? Because they have already been taken care of. When we apply operation on A4, we only need to care about making zeros in the range P4 to P8. Elements from P9 to Pn will be taken care by element A9, right? So we can break down our array into segments on the basis of number of zeros, right? So if my A4 is equal to 0, I can create a segment here. My A9 is equal to 0 here, so I can create a segment here, right? So let's call this segment 1, and let's call this segment 2, and let's call this segment 0. So I will create segments on the basis of index I where AI is equal to 0, and I will create segments on the basis of this. So in the segment 0, so if we find score in segment 0, the values P1, P2, P3 will never change. So your score in segment 0 is just the number of zeros, right? But for segment 1, let's say the most frequent element is F1. So we will set our x is equal to minus of F1, and by using this, our score will increase by frequency of F1, right? So in segment 1, we will find the most frequent element. Let's say the most frequent element is F1. We will set our x equal to minus of F1, and using this, our score will increase by frequency of F1. Now in segment 2, let's say the most frequent element is F2. But when we applied operation on A4, the value of F2 will reduce from F2 to F2 minus F1, right? Because when we applied operation on A4, F1 will be reduced from this entire suffix, right? So our previous frequent element was F2, but now the value will change from F2 to F2 minus 1, but the frequency will remain same, right? So value changes from F2 to F2 minus 1 because we applied operation on A4, but the frequency remains same. And for score, we only need frequency value, right? We don't care about the value of the element, we just need the frequency. And as the frequency is remaining same, I can just say my score is equal to score plus frequency of F2, right? So that is how we solve the problem. So we'll break down the array into segments. For segment 0, the score is just number of zeros. For the second segment, we will count the most frequent element and then set x equal to minus of F1. So my score will increase by frequency of F1. Similarly, for second segment, I will find the most frequent element. Let's say it was F2. The value of F2 will reduce from F2 to F2 minus F1, but we don't care about the value. We only care about frequency. So my score will just increase by score plus frequency of F2. So here for second segment, I will set my x is equal to minus of F2 minus F1. Minus of F2 minus F1. Similarly, if there are more segments, we will keep doing the same process, and that is the entire solution. So if I have to summarize the solution once again, I will summarize it here. Break the array into segments on the basis of indexes. AI is equal to 0, right? Then just iterate over the segments, and for segment 0, the score is just number of zeros. Otherwise, for other segments, find the most frequent element. Let's say it is Fi, then your score will increase by frequency of Fi, right? Now we just need to implement this, and if you guys want to see the code for this, here is the code. So I will keep a array v, this is my initial array, and I will keep a array pref, this is my prefix sum array. So I will input the array and I will calculate the prefix sum array. Then I will keep a map. This will help me to store the frequency. Then I will keep a boolean variable first segment. This first segment will help me to tell if I have reached segment 1, right? Because if you see here, the answer for segment 0 is very separated, right? For other segments, the answer is just the most frequent element and we just add its frequency. But for segment 0, we have to count the number of zeros. So I will keep a boolean variable called first segment, and this will tell me if I am in segment 0 or not. Then I will just iterate over the array, right? So here is the part. So if my p of I is equal to 0 and I am still in segment 0, right? So if my value of prefix is equal to 0 and I am still in segment 0, then I will increase my score. So if pref of I is equal to 0 and I'm still in segment 0, then increase the answer. Otherwise, if I find my AI equal to 0, I have to create a segment here, right? Because when I reach my value, I will create a new drawing so you can get it better. So I have A1, A2, A3, A4, A5, A6, A7, A8, A9, so on up to this, right? So when I reach A9, I have to calculate the answer for the previous segment, right? So this is my segment 2. So my segment 2 will start here. But when I start segment 2, I have to first compute the answer for segment 1. But when I reach segment 1 from segment 0, I don't need to do any computations here, right? So no computations are required. Because in segment 0, I just counted the number of zeros when I was iterating. So I just counted the score for this when I was iterating. So I don't need to find the score for segment 0. So when I reach segment 1 from segment 0, I will just set my first segment equal to false. That means I have just came out of segment 0. And when I reach from segment 1 to segment 2, I will count the most frequent element in segment 1, that is F1, and then do score is equal to score plus frequency of F1, and then go on to solve the answer for segment 2. And if you see the code for this, here is the code. So if my V of I is equal to 0, I will check if I just came from segment 1, from segment 0, I will set my first segment equal to false. That means I have now entered segment 1. And the second part is just if I came from segment 1 to segment 2 and so on, right? So in that case, you have to find the answer for the previous segment. So I will just change my score plus equal to current max. Here current max is just the maximum frequency of the element, because if you see at the end, I am changing my current max is equal to maximum of current max and frequency of pref of I. So I am finding the maximum frequency of the element using current max. And when I am done computing the answer, right, I have found the answer for previous segment. Now just reset everything and find answer for this segment. Right? So that is how the code works. And for the last segment, right, because if you see here, there is no segment 3. There is no segment 3. So how do I find the answer for segment 2? So I will just create a dummy segment 3. I will just pad my array with a 0. So I will just add a dummy 0 at the end. So when I reach this dummy segment 3, I will compute the answer for segment 2. So if you see here, I have defined my size of array as n plus 1. So I will add a dummy 0, and when I reach this dummy segment, I will compute the answer for my last segment. right? And in the end, I can just print out the answer. So if you guys have some doubts, feel free to jump into Discord server. I'll be more than happy to answer your doubts there. And I will see you guys in the next one. Bye-bye.